Alright guys, so we're starting the second part of Unit 2 today. That's 2.1 and 2.2. We're just going to briefly touch on 2.1. We're not really going to spend too much time covering it because the concepts are fairly simple and should be fairly easy for you guys. But as you see here, it has a table of different functions. So right here we have the constant function, which is usually just a line right here, a horizontal line, and it happens at whatever f of x. If you have like f of x is equal to a number, a constant, so f of x would just be a number, which would just mean it's a horizontal line like this, that's parallel to the x-axis. You have your linear function, of course, and we're all familiar with that. F of x equals x. Down here, you can see that we have the domain and range listed for these functions. And notice that the range for the constant function is only the number that the function is. So in this case, it's 1, so that means your range is only 1. For the linear function, it's all real numbers for both the domain and range, covers everything in both values. And then the absolute value function, which many of you might not remember from last year, but this is a v-shaped function. It's got these funny lines next around it. So the domain, you can see, covers all real numbers, and the range is just positive y. And then quadratic functions, which you guys might have touched on before, but we're really going to go over that in the next couple sections. This is what we're going to focus on. This is the squared function, where it looks more like a u, just like that. Again, all real numbers for the domain, and the range is greater than 0. Y is greater than 0. So just briefly, these are just quick transformations. I'm probably not going to go over them, but you can take time to graph something like these. As a refresher, I will graph number 7. So first I'm going to graph the parent function. So the parent function has a vertex right at 0, 0, right here. So start with the 0, 0. So plus 1, this plus 1 right here is happening outside of the absolute value function, which means it's a vertical transformation up 1 unit. So about right there, you'll have your new vertex, which is at 0, 1. Like that. There you go. That's what the absolute value of x plus 1. That's the function right there. Alright. So that's just a refresher. And then x squared, if it's negative, that just means that it's going to be flipped. So looking like something like that, just really briefly. Then for number 9, you have 1 over 8x squared. This 1 over 8 right here, that means that you're going to have a vertical shrink, and we'll cover what those are in just a little bit. And then right here, again, outside of the absolute value function is also a vertical stretch. If a is greater than 1, like right here, this 6 is greater than 1, that means you're going to have a stretch. But like right over here at number 9, 1/8 is less than 1, greater than 0, so it's going to be a vertical stretch. But we'll cover that in just a little bit. And then it asks us to graph the following functions using a graphing calculator. I'll just use Desmos, and I'm just going to do number 2, but you guys can look at number 1 and get familiar again with the absolute value functions. I would recommend that you do. But if we graph this one right here, we get something like this, and it's asking us to list the transformations. So you can see that we're no longer looking upwards, we're looking downwards, right? It's been flipped. And that's because there's a negative outside of our x plus 2 squared. And then we're also shifted away from the 0, from the point 0, 0. We're shifted to the left. We're left 2 units and then down 0.5 units. So to describe the transformations, we are left 2 units, down 0.5 units, and then reflected over x-axis. So again, I'd recommend going over these few examples. They should be fairly easy just to refresh your memory, but really I want to get to 2.2, which I think is where the real concepts where we want to cover today, the real transformation. So this is transformations of linear and absolute value functions. Next time we'll talk about some transformations of the quadratic functions. But right here we're going to talk about horizontal translation. So these are shifts right here. So the graph of y equals f of x minus h is a horizontal translation of the graph y equals f of y equals f of x, where h does not equal 0. So you can see here, these are what's important. This is what is important right here, these two right here. So whenever you're shifted to the left, you have h is greater than 0, and whenever you're shifted to the right, to the left, h is less than 0, and to the right, h is greater than 0. So what that means, just for example, let's say that you have a number, so h is less than 0. Let's say h is equal to -2. -2 is less than 0. Let's plug it into our function that they give us. So we say y equals f of x minus, and h is -2, so we write it like that. Well, if we simplify that, then we get f of x plus 2. So you can see that positive, this being positive, means we're going in the negative direction. And then if we did h is equal to 2, so greater than 0, then we get y is equal to f of x minus 2, right? And so you can see that whenever we're negative, like right here, we're going in the positive direction. So that's why you read it backwards. So let me just write that down for everyone to remember, that whenever you have a positive number, whenever you're adding, you're actually going left. When you're negative, you're going right. And remember, we're talking about a horizontal shift right here, horizontal. And that's whenever you have an x minus h inside of your parentheses. Now compare that to vertical transformations right here of the graph y equals f of x plus k. Notice that this k is not inside of our parentheses, it's outside. That means it's going to be a vertical translation, not a horizontal translation. And then you can see here that when we're going upwards, k is greater than 0. When we're going downwards, k is less than 0. Okay? So whenever your positive number, whenever k is positive, you're moving up. Whenever it's negative, you're going down. Again, if you compare that to the horizontal translation, whenever you're positive, you're going in the negative direction on the x values, and whenever you're negative, you're going in the positive direction of x values. Notice the difference here, though. You can see that we have inputs versus outputs. Inputs are your horizontal, your x values, and outputs are your y values. Okay? We're gonna notice a trend here. Okay, the next transformations we have are the reflections. So reflections across the x-axis right here, across the x-axis right there. And that looks like this right here when you have a negative f of x. So it's flipping across this axis right here. You can see that we start going this way, but now we're mirroring it across this line, the x-axis. So that's a vertical reflection compared to reflections across the y-axis, you can see here that now we're reflecting across the y-axis line right here. It's like we're mirroring it across the y-axis. And that looks like this whenever you have a negative x inside of your parentheses, okay? Again, notice that we're talking about inputs right here and outputs right there. On the outputs for the vertical, I'm going to write that in here. This is a vertical reflection, and this is a horizontal reflection. Okay, notice that whatever happens inside our parentheses, like here and on the horizontal translations right there, we have a horizontal change, while anything that happens outside, like f of x plus k or negative f of x, then it's a vertical transformation. Alright, vertical stretches and shrinks the graph of y equals a plus f of x. So let's make a guess. We have a multiplying by f of x. A is outside of our function, so that means we're going to have a vertical stretch. Again, it's going to affect our outputs, which is our y variable. And then if a is, so you're going to have a vertical stretch or a shrink by a factor of a of the graph of y equals f of x, where a is greater than 0. Okay, multiplying the outputs by a stretch, by a stretches the graph vertically when a is greater than 0. So that means it's a stretch when a is greater than 0, and it's a shrink when a is between 0 and 1. Okay, so again, look at it over here. When a is greater than 1, you're stretching it this way vertically, so away from the x-axis. Alright, and then you have downwards, you stretch it downwards whenever a is between 0 and 1. Alright, so that's a shrink. So this is a shrink, and this is a stretch. A is greater than 1, it's a stretch, and it's a shrink when a is between 0 and 1. Okay, those are vertical stretches and shrinks. Again, they're happening vertically, like this. Vertically. Compare that to the horizontal stretches that are happening horizontally, like this. Okay, so the graph of y equals a of x, right there. Compare that to our vertical stretches, which again, the a was outside of our function, and now we're talking about a being inside our function, is a horizontal stretch, or shrink by a factor of 1 over a. Instead of here, it was a. Here, horizontal stretches are 1 over a. Alright? Of the graph y equals f of x, where a is greater than 0 and not equal to 1. So the inputs, again, inputs are your x values. By a, so multiplying the inputs by a before evaluating the function stretches the graph horizontally away from the x-axis, so it's a stretch whenever a is between 0 and 1, and a shrink when a is greater than 1. So all of this is opposite than what we said about the vertical stretches. When a was greater than 0, it was a vertical stretch. When a was less than 1, greater than 0, it was a shrink. But now horizontally, we read it backwards, okay? So when a is greater than 1, that's going to be a shrink. So that's going to be going towards the x-axis, and then it's going to go away from the axis. This is going to be a stretch when a is between 0 and 1. Alright? So let's put this to practice, okay? So in exercise 1 through 9, write a function g whose graph represents the indicated transformation of the graph of f. Use a graphing calculator to check your answer. Alright, so for this first one, let's first identify what we're dealing with. This is a 1 over 3x, and it's happening inside of our absolute value signs, right? Okay, so that would be a vertical shrink. But it's asking us to look at this right here. This is the part that it wants us to look at. So we want to translate this function to the left 2 units. So let's write down our function right here. So if we go back up to the horizontal translation, we said y is equal to f of x minus h, right? Okay, now what is h in this case? Well, h is 2 right there. So h is equal to 2, but we're saying to the left 2. So h is equal to negative 2. Okay? So then we'll have, let's put it into our new function, g of x. And we say g of x equals f of x minus negative 2. Like that. So let's plug that into our function now. So then this is equal to f of x plus 2 if we simplify, which is equal to 1 over 3. Now instead of x, we're going to put whatever we have here, x plus 2. Okay? So if we simplify that, we have 1 over 3 x plus 2 over 3. So that's what our new function is. That's what g of x is. Okay? So again, if you want to do these, identify the function that you're going to use from above and figure out what your value is. So our h was negative 2. Let's try number 2 right now. So we have another, let's see right here. So this is our function right here, and we're saying we want to translate 6 units down, okay? So if we're going down, our function would look like this, y equals f of x plus k, correct? And then we're going down, so k is equal to negative 6, alright? So g of x, if we're going to write our new function with the new transformation, we're going to say g of x is equal to, and then we have f of x. Remember, this is f of x right here. And then we're saying we want to shift this function down 6 units, so minus 6. Okay, so negative absolute value of 9x plus 9 minus 1, and then we're going to say minus 6, right? This was our f of x, and this is our translation 6 units down. So then we just have to combine like terms right here. So negative absolute value of x plus 9 minus 7. And that's our new function. I'll let you guys do number 3 because it's just a linear function. But I'm going to go to number 4, and we're going to talk about a reflection. So reflection in the x-axis, okay? So the function above said y equals negative f of x. So our g of x, our new function, is negative f of x. So again, this is our f of x value, so we're going to just replace f of x with this. So this is equal to negative, and then we have 1 over 2x plus 8. And then if we distribute that negative, we have negative 1 over 2x minus 8. Alright, so again, this is a reflection across the x-axis. So we're going to flip it over the x-axis like that. Okay, for number 5, a reflection in the y-axis. So that was y equals f of negative x. Okay? So g of x is equal to, and then where we see x in our function, we're going to replace it with negative x is equal to, so we say f of negative x, which is equal to 4 plus absolute value of negative x plus 1. So what this did was flip our this is the y-axis. So we flipped our function across this. We mirrored it across the y-axis there. Okay. Jumping to 6, we say vertical shrink by a factor of 1/5. Okay, now let's remember, if we go back up and we look at the vertical shrink, it was y equals a times f of x. And vertical shrink meant that a was between 0 and 1. In this case, our a is 1/5. Okay? So by a factor of 1/5. Okay, so now let's write our new function, g of x, which is equal to a times f of x. So a is 1/5 times f of x, and this is our f of x right there, so this is equal to 1/5 times negative 5x, so that's going to end up equaling negative x. So we just shrunk our function of negative 5x by a factor of 1/5 vertically. Okay, for 7, a vertical stretch by a factor of 4. So we're still talking about a vertical stretch, so that's y equals a times f of x, but a is greater than 1, a is equal to 4, which means we're going to stretch by a factor of 4. So g of x is equal to 4 times f of x. This is f of x right here. So rewrite this as 4 times absolute value of x plus 3 plus 2, like that. So we have to distribute this 4 here for the x plus 3 and to the 2. So it's going to be 4 times x plus 3 plus 8. So that's what a vertical stretch would look like. Alright, now for 8, it's talking horizontal stretches, okay? So this one's different. We have to read these backwards than the vertical ones. So we're saying a vertical stretch by a factor of 6. First, let's write our function for horizontal stretch and shrink, which was y equals f of ax, okay? So again, this, if you go back and look at the definition, it said that it's by a factor of 1/a, okay? And we said that a, so we say 1/a is equal to 6. Not a is equal to 6 like it was in a vertical stretch or shrink, because again, up here, it said horizontal stretch or shrink by a factor of 1/a, and we're saying horizontal stretch by a factor of 6. So 1/a is equal to 6. We can simplify this to be a is equal to 1/6. Okay? Alright, so a is equal to 1/6. Okay, so we have g of x is equal to f of a, and a is 1/6 x. So equal to, so what we need to do is plug 1/6x right into our x value. So 3 1/6x minus 9. And that's equal to 1/2x minus 9. And then a horizontal shrink by a factor of 1/4 for number 9. So again, let's write our function, y equals f of ax, because it's a horizontal shrink. And we say 1/a is equal to 1/4 by a factor of 1/4, right? So here you can clearly see that a is equal to 4. So a is equal to 4. So g of x is equal to f of a, which is 4x. So what we need to do is plug this right there into our x spot, 4x into our x spot. So this is equal to negative absolute value of 8 times by 4x minus 4. And that's equal to negative absolute value of 32x minus 4. Alright, so hopefully that, I think that does it for this lesson. Again, go back through these right here, these core concepts right here, and memorize, get familiar with these functions right here. These functions are the key in knowing how to identify your h, your k. The reflections are pretty easy, but still remember them. And then your a values and what that means whenever a is greater than 1 or between 0 and 1 for both your horizontal and your vertical strengths and stretches. So go back through, memorize those. That will help you a lot when recovering this unit. Alright? Okay, I'll see you guys in class.